Okay, so here we're going to take a look at some common Maclaurin series. I'm going to start by deriving one common Maclaurin series. So we want to find the Maclaurin series for the cosine function. Okay, so here we'll start again. Our function is the cosine of x. Right, the first derivative is negative sine of x. Second derivative is negative cosine of x. Third derivative is positive sine of x. Right, and then the fourth derivative, we're back to cosine of x. Right, and we could really see that at this point, right, it's just going to cycle again, right? If we're back at the beginning, right? So we have a complete cycle here, so we can just have the first four derivatives here. We know it's just going to repeat here. All right, so evaluated at 0, since it is a Maclaurin series, you get 1, f prime of 0, excuse me, is 0. F double prime of 0 is negative 1. And f triple prime of 0 is 0. All right, and if we keep going around, the fourth one is 1, and then we won't get another value to the sixth derivative, which is negative 1. So it looks like we have an alternating series, right, where, excuse me, and we have an alternating series, right, where all the even numbers are the only powers that show up, right? 0, 2, 4, 6, etc. Right? So the Taylor series, the Maclaurin series expansion, right, for cosine of x looks something like this, right? 1 over 0 factorial x to the 0 minus 1 over 2 factorial x squared plus 1 over 4 factorial x to the 4th, etc. The next one's minus. And now in its general form, right, the series notation, I can write this as m to the 0 equals 0 to infinity, right, negative 1 to the n, x to the 2n over 2n factorial. So that is our Taylor series expansion. Now, in terms of the radius or the interval of convergence, let's take a look at the ratio test. Right, so the ratio test gives me x to the 2n plus 1 over 2n plus 1, the whole thing factorial, times 2n factorial over x to the 2n. Okay, and here, simplifying, right, we get x 2n times x squared times 2n factorial. Now, here, 2n plus 2 times 2n plus 1, and then 2n factorial, right? Doing the factorial expansion, so we can reduce here x to the 2n. All right, simplifying here, we get here, and we're left with the absolute value of x squared over 2n plus 2 over 2n plus 1. So let's take the limit of this. So the limit as n goes to infinity of a sub n plus 1 over a sub n. Right, that goes to absolute value of x squared. I'll take it out the limit since it does not depend on n. And inside we get 2n plus 2, 2n plus 1. So n only shows up in the denominator. So as n goes to infinity, the denominator gets infinitely large. So the whole limit goes to 0. Okay, so what that means is that my interval of convergence is from negative infinity to infinity. The radius is infinity. All right, so that is our Maclaurin series for cosine function, right? And in general here from our textbook, we can see here these some common functions, right? A lot of these we've derived already, right? Or we worked with extensively here, but here's a nice list, comprehensive list where it has the function, the Maclaurin series. Again, right, Maclaurin's just a specific instance of the Taylor series. It's centered at 0, and its interval of convergence.